All right, we're going to look today at Unit 11, Day 5 notes. We should remember from Algebra 1 the inverse of the function. We're going to replace the y with the x. And we see, as you can see here, switch them and solve just like we were doing when we were doing the inverse function and as we were graphing over the y equals x line. So your inverse function of y equals 3x plus 1 will be 1/3 x minus 1/3. Okay? And as we do this, okay, remember the function rules, we want to find what f of 5 is. So as we plug in, 5 goes everywhere, x does, we get 16. Well, if we find f inverse of 16, we plug in, we will get 15 over 3, which is 5. Well, if you notice, f of 5 is 16, which is the same as the inverse. Our inverse is our x and y switch. Okay. So now on the previous page, if we use the same f of x and f inverse of x, okay, they want us to know now, okay, this compound one. So we know that inverse of x is 1/3 x minus 3. Plug that in, okay, distribute, so we get x minus 1 plus 1, okay? Well, the plus and minus 1's cancel, so we're left with x. Same thing over here, if we switch the order, distribute the 1/3, so x plus 1/3 minus 1/3. The 1/3s go away and we're left with x. So anytime you do the inverse of a compound function, you will get that variable. You will get x or whatever number's in there. So for example, if we look here, if this is our f of x, okay, and they want us to know f of f inverse of Jack Bauer. Well, if you remember, Jack Bauer was from the show 24. So we plug in, we find our inverse. So our inverse function is y equals x over 4 plus 3/4. So over here, we go with the inverse, plug in 24. Okay, so if we show it, that's 6 plus 3/4, which is 27 over 4. Well, now plug that into there, and we get 24. Well, if we remember, it's still x, so we're left with what's in the parentheses, x. Well, instead of doing all this work, we could have just realized what's in the parentheses, Jack Bauer, 24, so our answer would have been 24. Okay, we do have some inverses that do not have, or some functions that do not have inverses. So for example, in order for a function to have an inverse, okay, it has to pass a function vertical line test. So for example, if we look here, y of x squared is here, okay? Now, when we do the switch and we get our new inverse, that's the square root plus or minus the square root of x. Well, the square root of x plus or minus graph looks like this, a rough sketch. And you know it's not a function because it does not pass the vertical line test. Okay, so now how we could realize and shortcut this is what we call the horizontal line test. So as we could look back on this page, what did we do with the graph? The graph turned to be this way. And instead of looking at the vertical line test of the inverse, we could look at the horizontal line test of the original function to tell whether we have an inverse function. So for example, if we graph the absolute value of x plus 1, okay, it's right here. Well, if we do the horizontal line test, as you can see, we hit the graph twice. So because we hit the graph twice, no, it does not have an inverse function. Okay, last page of notes here. Part C, okay. We want to know, does this have an inverse function? So the easiest way to do it is either graph it on your graphing calculator or have a rough sketch like I do here, okay? As we know, as we come up, our zeros will be right here at -1, okay? At +2, this would be +2/3, and here would be +4. But what we know is at 2, we have a bounce off and we stay negative. Well, right there, when you see that, as we go through the graph, you could see it comes down through. You could see it does not pass the horizontal line test. So right there, we could say, no, it does not have an inverse. Down here, I know my graph's a little messed up, but we're looking at this line right here. I accidentally graphed the inverse on here as well. Okay, so the inverse is here. This would be your actual function. Well, because they're both lines, they're always going to pass the horizontal line test. So yes, there is an inverse. But when we say to write the rule, that means actually find the inverse. So as you can see, I switched x and y, solved. So my inverse function is 1/12 x plus 7/12. Okay, and like we did on the last page, show that this is equal to x. So I plugged in the inverse into the actual function, x plus 7 minus 7. It gives me x, and over here I switched it. So 1/12 of 12x minus 7 plus 7/12, I do get x. So yes, it does equal x both times. If you have any questions, please message me. Again, pause the video as needed.